All right, testing a proportion. We are in 8.3 and proportion is lowercase p. We'll be doing our same 5 steps that we have done previously. So let's go through these and look at what is similar and what is different. So step 1 is always set up your hypotheses, which is your null and your alternate. So p will equal some value, this will get within the problem, and then your alternate will be either less than, greater than, or not equal to. So step 2 is calculating your test statistic. And if you'll notice, this is a z value, and here is that formula that we will use. It will be p hat. And over here, recall that p hat is equivalent to r, your number of successes, over n, minus p, and p is the proportion that we set up here in the null, divided by the square root of p times q, so q will be 1 minus p divided by n. So this is what we will do for our test statistic. After we have found our test statistic, then we will find the p-value by using the z-table just like we did in section 8.1. So if it is a less than statement, which would be determined by your alternate hypothesis, you just use the number from the z-table. If it's greater than, 1 minus the number from the z-table, and then if it is not equal to, then you have z is between these two, and TS stands for test statistic, okay? All right, so then step 4 and step 5 are exactly the same. So step 4 is when you compare. If the p-value is less than or equal to alpha, you reject. And when you reject, you have sufficient evidence. If the p-value is greater than alpha, then we fail to reject, which means we have insufficient evidence. So a lot of this is similar to what we have already done. So now we're going to do a couple of examples. All right. At the 0.01 level of significance, test the claim that the proportion, so we know we're talking about p, of voters who favor nuclear disarmament is less than 0.7. They give us sample data consists of 50 randomly selected voters, of whom 31 favor nuclear disarmament. All right, so step 1 is setting up your null and your alternate. All right, my null will be p is equal to some number, and what that is 0.7, and they're testing the claim that p is less than 0.7. All right, so since this is a less than, then I know that my z, we have a left-tailed, such as this. All right, so step 2 is your test statistics. So we're going to be using this formula, which means we need to calculate a few more items. All right, so this is my test statistic. We know that p is 0.7, so we can find q, because those are complements, so that must be 0.3. We are also going to need p hat. Well, to calculate p hat, you do n and you do r. Well, that would be the sample data was 50, and of those, 31 favor the nuclear disarmament. So now that I have my n and my r, I can find p hat, which would be 31 over 50, and you plug that into your calculator and it gives you 0.62. Now I'll have all the necessary calculations to find my z. So the z is equal to p hat 0.62 minus P, which is 0.7, divided by the square root of P, which is 0.7, times Q, which is 0.3, divided by N, which is 50. So here's what it looks like in the formula. I'm going to show you how to do it on two different calculators. So on this one, I can use the fraction button. So in the numerator, I'd have 0.62 minus 0.7. Then I'm going to down arrow and do the square root. And in the square root, I need another fraction, 0.7 times 0.3. Down arrow, 50. And then I'm going to right arrow all the way out to the right and hit enter. Whoa. Oh, I put in 27 accidentally instead of 0.7. I knew that number was way, way off. So let's do that again. Fraction, 0.62 minus 0.7. I actually accidentally hit the 2. 0.7. And then I'm doing the square root. And then another fraction of 0.7 times 0.3. Down arrow, 50, and then I'm going to right arrow out. Now this should make more sense. Yes, negative 1.23. Makes way more sense. All right, if you're using this calculator, you're going to have to use parentheses. So you would do open parentheses, 0.62 minus 0.7, close parentheses, divided by the square root of 0.7 times 0.3 divided by 50, and then close that radical and hit enter, and you get the same answer. So there's the two calculators. All right, so we have found the z to equal negative 1.23. So now we're going to go to step 3, which is finding our p-value. And since our alternate is a less than, then I'm finding the probability that z is less than, and our test statistic was negative 1.23. And since it's a less than, then I go straight to negative 1.23 on my table, negative 1.20123, and I get 0.1093. So then on step 4, I'm going to compare the p-value, which is 0.1093, which is equivalent to 10.93%, to alpha. And alpha is 0.01, which is 1%. Well, as you can see, the p-value is greater than. And when it's greater than, we fail to reject. And if we fail to reject, that means we have insufficient evidence. So, there is insufficient evidence to conclude that, whoops, I got to be able to spell that, the proportion of voters who favor nuclear disarmament is less than 0.7. So there's my conclusion, insufficient evidence. All right, we're going to do one more example. An airline reservation system suffers from a 7% rate of no-shows. Now, 7%, if I wrote that as a number, 7% is 0.07. A new procedure is instituted whereby reservations are confirmed on the day preceding the actual flight, and a study is then made of 5,218 randomly selected reservations made under the new system. If 333 no-shows are recorded, test the claim that the no-show rate is lower with the new system. Okay, so the null is that the proportion is equal to 7% or 0.07. The alternate, they're testing the claim that with the new system it would be lower or less than 0.07. So once again in this one, we have a less than. Just don't forget, if it were to be a greater than, when you get down to the p-value, you would have to do 1 minus the number from the table. So just refer back to the first page of the notes. But we have a less than again. All right. So on step 2, which is our test statistic, all right, we know that P is 0.07, so I know Q is is it 07? Yeah, 93, sorry. Had to make sure on that number. Okay, then we need P hat, so I know I need N, and they used 5,218 randomly selected reservations, and of those, 333 were no-shows. So my P hat is 333 divided by 5,218, which is 0.06. So now I have everything that I need to calculate my test statistic, which is a Z. So it is P hat, 0.06, minus P, which is 0.07, divided by the square root of P times Q, so 0.07 times 0.93, divided by N, which is 5,218. So we're going to put that into the calculator. So fraction 0.06, not times, minus 0.07, denominator, square root, fraction, 0.07 times 0.93, and then I went down to put in the 5,218, right arrow out of everything, and hit enter, and I get negative 2.83. So my Z is negative 2.83. I'm going to go ahead and calculate it on this as well for those of you that need it. So I would do open parentheses 0.06 minus 0.07 close parentheses divided by the square root of 0.07 times 0.93 divided by 5,218 close equals, and I get the same answer. All right. So then we're going to find our p-value. And again, since it's a less than, we're going to see the probability that Z is less than negative 2.83. So again, since it's less than, that's the easier of them all because you just find the number from the table. Just don't forget, if that was a greater than, you'd have to do 1 minus the number from the table. So negative 2.80123, so it's 0.0023. So now we are going to compare our p-value. 0.0023 is the same thing as 0.23%. So this is really small because it's less than 1%. And we're going to compare that to alpha. And alpha, it's said to use 5%. Well, when I compare these two percents, the p-value is obviously less than. Less than tells me to reject the null, and when we reject, it means we have sufficient evidence. So there is sufficient evidence to conclude that the no-show rate is lower or less than 0.07. So that just basically says that the new system is working. So the no-show rate has declined from what it used to be. So that is 8.3.